always when it comes to API security, we need to look at from the hacker's perspective. Right? And then we will look at what are the ingredients that will help us to build better API security and set up concepts around that. Right? Because I personally believe when it comes to API security, it's not about authentication or authorization. There are many other metadata, many other facts that we need to consider. It's a multifaceted entity, so we need to look at in different approaches. We need to look at other areas that we need to consider when it comes to API security, like throttling, monitoring, and we need to have a business flavor in API security. It's all about, at the end, it's about business, right? Whether we could provide the business capability without friction. So let's go ahead. So let me introduce myself. So I'm Dassana, and I'm from Ws2. I'm based out of Sydney, and basically looking after the solutions architecture for the region. I have been with Ws2 for almost 9 years now. Yeah. So let's look at let's just wear the hat of a hacker, right? So if you want to look at or hack an API, you need to look at what it means by API attack surface, right? You know, think where you can attack, where the vulnerability is. So if you look at APIs, API comes with the API definition, right? So this is a sample API definition from the Hilton API Developer Hub. And if you go through this Swagger file, right, so it clearly mentions what the API is, what is the data model it serves, how you can access, and as well as the API behavior. So a lot of details are available in the API definition itself. Right? So a hacker can basically go through this API definition and understand how the API is behaving, and as well as he could understand any vulnerabilities or any areas that can be an API attack surface. So basically what we are saying is like the API definition like Swagger, RAML, API blueprint, those definitions provide provide a door to a hacker, right? So you have to be, so there are two paradigms here. You need to sell into developers by providing or explaining what the API is doing, but as well as you need to make sure that you build and secure your API in a way that it is not creating any vulnerabilities. Right? So there are two aspects of it, right? You have to be descriptive about your APIs. You need to have that API tooling which allow people to test your APIs, things like that. But still, you need to have the security in place. So, and if you look at, again, like if you access an API, right? So this is one of the Google Translate APIs. And when I call this API, well, let me show you by calling the API. So this is the supported languages, right? And if you look at the headers that is coming in, sorry, the headers that is being passed by the server, so I can see that this is being implemented using MS. There are a lot of details coming out. Right? So a hacker can actually understand how it is being built, right? More than, I mean, this information, some of the information that we see here is not necessary, right? So if you look at from the API definition perspective, yes, you need to provide a lot of details to allow developers to use APIs, but this information that is coming back, you have to be careful, right? You have to have a delicate balance between what the information that you share and as well as what you are not sharing. So, because by understanding which API gateway or the API platform these APIs are hosted, you can look at the known vulnerabilities of those platforms and targeted, right? So you shouldn't expose your implementation details in an API. So you shouldn't send some of these headers on the API. So you have to be careful. So this is important, what to share and what not to share, right? So this builds that attack surface for the hackers, right? So going back to the slides. So this is the different headers and information that are coming in. So again, coming back to the statement that I have made, API security is not just authentication or authorization, right? So if you look at the philosophy of API security, it is combination of multiple aspects. Yes, you need to identify the request origin, from where this request is coming, and look at any anomalies in there. And then you need to do payload validation, right? Whether it conforms with the data model and the access model. Then comes the authentication and authorization. Once we do the authentication and authorization, we bind the identity, or we know the identity of the API consumer. And then we can relate that to different throttling policies, different usage policies, the way that we allow the consumer to access APIs. So because we have already established this identity at the authentication and authorization level, we can build these business layers around the usage. And we need to do monitoring. We need to understand how the API is being used and continue to monitor the usage of these specific consumers. And all of these factors has to be driven by the business, right? Because the ultimate aim is to allow the APIs to be consumed, right? So we shouldn't the security shouldn't make a friction for API usage, and it should be driven by business, and which means the API security should be dynamic, right? Based on the consumption pattern, based on the identity of the consumer, the different throttling tiers, the security has to change, right? It is not a static thing anymore, and everything has to be driven by business. So if you look at the request that is coming in, right? So if you look at the origin, so there are many metadata that comes with the API request. We can look at the IP addresses, the regions, and things like that, and build a pattern which we allow several specific consumer to use the API. And we have these metadata like scheme, domain, path, related to the APIs being consumed. We have the HTTP headers, and we have the HTTP payload. By combining all of these metadata, we can create a profile, and based on that profile, we can establish a security model. So we can allow API requests that are coming from a specific region, and as well as we can check the headers that are coming in, the URL patterns, the query parameters, and things like that. Right? So this is the structural validation that we are doing. Now the problem is, when you are doing this structural validation, it takes time. It takes CPU cycles, right? So you need to understand, you need to implement the minimum validations that you need to do, and it has to be dynamic as well. Simple example is, if it is internal API request, we might not do the validations or security steps that we do external API request. So it has to be dynamic, right? So if you look at implementing API security, now here what we are trying to do here is we are coming into the authentication and authorization step. There are different ways of implementing API security, from basic auth to digest auth, the token-based API security mechanisms and all. based on the type of API, whether it is internal and external, you can choose the API security model. You don't need to implement OAuth or IDC for all the APIs, right? The same API can be exposed with different security models, right? The platform or the API gateway or the API platform that you have should be able to do that, or you need to build that capability within yourself. Because what we are looking at is frictionless API consumption. So when it comes to basic authentication, it's just, we are passing the username and password with base 64 encoded, right? And so with this username and password, we are establishing an identity. And this identity can be a person, a device, or a system, right? It doesn't need to be always a person. And it can be a combination of system and a person as well, right? A person using a system. Based on the business services behind this API, you can choose. This is the simplest API security model, right? And if you look at this API security model, you are passing credentials over the wire. And with HTTPS, you can have the confidential, but still there is vulnerability in the security model. But still you can choose it, like based on the API that you are serving. Second is digest as a little bit improvement on the basic authentication. So here we are hashing the information, the identity related information, and then it goes to the resource server. Yeah, so we can choose this type of API security for your APIs as well. Now comes the API keys, right? So we can use API keys passed on the API request. It can be on the URL, it can be on a HTTP header, and you can pass it to the server. As I said earlier, there can be a situation where the same API can be accessed using basic authentication, and as well as it can support API keys. So we need to have that flexibility because in different scenarios, the same API can be in different consumption models. So we need to encourage that flexibility when it comes to API security implementation. So this is this interaction diagram is actually from Consumer Data Rights Program, Australian Consumer Data Rights Program. This is Oidc, Oidc API security model. So it's complex, right? And again, it's a way of securing an API using API tokens. And there are different levels of securing that API. You can choose between the level of API security that you want to implement based on the need. Now, so there are different ways of securing an API, coming from basic authentication to API tokens. Now it comes to the level where we can go granular. On the API, we can choose to secure at different resource levels, right? Not the API, but have different roles or different authorization mechanisms at the resource level. So you can serve different roles in a different way. So this basically means that you have passed your authentication and authorization step, and you have identified or established the identity of the consumer, right? And the same consumer, it can be a system, it can be a person, will have different roles against different APIs exposed by the same system. Based on the role, you will have different access to different resources. So this is the API resource level access. So you can implement your security and go to that level of granularity. You can stop at the API level, or you can go into the HTTP method, the resource, and sub-resources as well. Now, if you club all of this together, basically what you are doing is you are applying different security policies at different levels of API consumption or API round trip. First, you do the validation here. So you are basically doing the structural validation. You establish that blacklist policies, whitelist policies. Some of these security policies can be established on the firewall or the proxies in front of the API gateway, or you can implement that on the API gateway. Moving these validations to API gateway adds more value, because usually what happens is API gateways are able to host business policies, bring those policies together, right? But the downside is, if you compare it with the hardware accelerators, it takes time. You will have performance concerns. So that's the structural validation, and it usually go through set of this is the Ws2 Api Manager implementation, but mostly in most of the products what would have is like there will be set of intercepting filters, like building blocks sit on the API request path, applying different policies. It can be like protocol validations, and it can be the header validations, and then it can be throttling validations. Before the throttling there will be security validations and things like that. So it's always a sequence of activities performed on the security, the API request path, and the platform that we are using to implement the API security should be able to plug these components, at different places on the API value chain. Right? So you should be able to plug and play different filters. It's like putting intercepting filters, and you should be able to tie them into a business policy which can be dynamic. Right? So that's the model which we should have, and these different filters or policies that we apply should work fast on this API request path, right? Because we haven't served this API consumer yet, right? We're still doing validations, applying security policy. So this should be quickly, the API request should quickly go through, and as well as there's this monitoring and auditing aspect as well. So those monitoring and auditing aspects should run parallel to this request path without being invasive to these application of different security filters. And the other thing is, I especially wanted to look at throttling, because not only authentication and authorization, the throttling is a part of security as well, because you are safeguarding your runtime against unnecessary usage, right? And when it comes to throttling is applying a certain limit to the usage, right? Yes, you can apply a limit to the usage, but then what, right? Are you stopping it at that level? You stop it, like just stop at 70 TPS, right? And bring down, make it 0, the consumption. Or will you allow it to, grow a little bit further and reject additional requests after some time? Or will you move that consumer into the next tier? Right? these are business decisions, right? Because we don't want to stop consuming the API, right? It's not good for the business. Like saying, okay, you go ahead, you're going beyond 70 TPS, I'll stop you, right? So what we usually need to do is like, okay, you need to first notify them, right? You are consuming more than than the subscription tier that you are in. Then take some time and then bring down or reject requests that are going beyond 70 TPS. So these are the business decisions, and these business decisions can be dynamic. Some of the consumers we will allow, say government, right? We don't want to have these royal commissions coming in, so we'll allow them to consume a little bit more, right? Something like that. So which means there's a dynamic component that bound into this data plane which actually performs the throttling or where the throttling is applied, and there should be a flexible relation, like link into these dynamic policies when you are applying the throttling policies. And the other thing is you should have a kind of a developer experience or business analyst experience given by your platform to build these kind of models, right? Should be flexible enough. So now if you further expand this, right? Now the throttling can be applied in different levels, right? So you can, like, so what happens is we model the API consumer as an application. Yeah. And this application can be used by different people, right? Say admin, right? And we should be able to apply different quota for each user. And there can be a quota for the application as well. Right? So this is application level policy configuration. And again, we need to have some kind of burst control in place. And there are subscriptions per application, different subscription levels. And how we apply subscription can be dynamic, like whether to stop or allow them to kind of grace period and then stop. And then you apply throttling, and there are resource level throttling as well. And you apply, based on the executive method that you use. And you need to look at the API backend as well. So if the API backend cannot handle this load, there should be a feedback loop coming in and modifying the API backend. So you can apply different throttling at different levels, and it should be dynamic. And it is part of security. So, sorry. Now, API security is not just these functional aspects, right? There are non-functional aspects as well. So, if you look at this dashboard, right? This dashboard is the performance dashboard of consumer data rights program, which is maintained by APIscene. So, now you can see that with the bank firefighters measure has 8.995 seconds response time for unattended API requests. So not only, so the availability and performance is part of the security as well, API security. Because if we cannot serve the API responses in certain amount of time, the API consumers will no longer use the API because it's not performing enough or getting the data at the right time. So we need to consider them as well, and it has to be part of the security as well. And when it comes to performance and availability, you need to build your API gateway and APIs in a way that it can scale based on the load. Because we are looking at allowing API consume to consume. So the API, the data plane that you have should be able to scale and have that APIs hosted and being served for the API consumers. And so when it comes to consumer data rights, so they have this definitions. Right? So there are minimum performance goals set. There is availability set, 99.5. And there is this throttling limits defined for these APIs, both product APIs and consumer data APIs.
Stephen, what's the definition of unattended?
So unattended is there is no user involved here. So the system is calling an API. So there is no active user at this time. That's the definition of unattended. So it can take 4 seconds. So there are different API groups in the CDR consumer data rights specification, and these are the mandated non-functional requirements that is defined for the consumer data rights. So again, the concept that I want to build here is like security includes scalability and availability as well. Now, in order to enable this API security, you need to have a modular design in your API gateway or the API platform. So, I'm taking an example from Ws2. So, if you look at Ws2 API gateway, the API gateway composed of multiple components. So, we have the API gateway component, which is the data plane, and we have a traffic manager, which where the actual throttling policies are located, and as well as the throttling decision engine is located. Right? And these throttling policies can be, so there's a developer experience that we have built, which can use to build these different throttling policies. And in order to build these throttling policies, we make available an API context. This API context has many metadata, like the URL, the request metadata, the payload. So that is available as an in-memory context, and you can build these throttling policies based on those metadata that comes with the request, and as well as the information you generate from API tokens, which identify the person and the system. And the other thing is, for these throttling policies or the throttling manager, the traffic manager can be integrated into backend to have a feedback loop, right? Which means you can have a dynamic system which enables real-time modification of the throttling policies. So this is similar. This is same model applies to authentication and authorization. So what you can do is you can apply adaptive authentication to the API gateway, where based on the payload and the query parameters, you can change or you can change the scope of the security. So you can augment security. So if it is like, say if it is a bank and this API is only looking at getting the product details, we'll have a lower level of security, but it is making a payment, and we can increase the challenges that we make for the API consumer from the security perspective. So what we have done is we have make it modular, like each component is having a specific role. The data plane is where the decision is actioned, but the decision, the policies are defined in a separate module. So you have the extensibility of bringing in business capabilities or business policies into the API security. So this is the kind of detailed kind of architecture of Ws2 Api Manager, which is so we have the data plane as API gateway, and it basically sends events to a message broker or eventing platform within the product, and based on these events the policies are applied. Again the throttling policy decision is communicated back to the data plane. That's how it works. And for this policy decision making, we are using a real-time analytics engine, so you can plug in different event sources other than API requests and related events. So it can be dynamic, based on different business policies, the changes that are happening on other ecosystem systems. You can change these business policies. Like it can be throttling policy, it can be security policy, maybe structural validation policy. You can bring that into the picture. So it creates a dynamism in applying the API security. So if you look at, if you bring all of these concepts together, so if you look at how different, like in an API, when you're implementing an API security and what kind of steps that you will take, so usually what happens is you first do the structural conformance, then you do the authentication and authorization. Then, so you establish that identity within authentication and authorization, identity and role, and then you do the business validation. Now, once you have identified the consumer, you can bring in throttling policies and business validations into the picture, because until we establish the identity, we cannot bring, we cannot relate or link these business validations related to security into the API request. And they have to be dynamic. So once the identity is established, these policies can be dynamic and applied against the API request. And there can be situations where we need to consider the backend throughput as well, based on the load that is created on the backend by these APIs. And we need to look at multiple systems as backend. So there should be a feedback loop that feeds in events to these steps, saying that okay, I cannot take the incoming new request, I am full, kind of thing. So the platform should be able to support these feedback loops, create like the feedback that is coming from the backend throughput will be part of those dynamic policies. And each step, there will be an audit trail. There has to be an audit trail because we need to understand whether the structural conformance is working, and if not, why. Same as authentication and authorization. So we need to have a correlation ID across all of these steps to identify the flow of the request. By having this feedback loop and making, or rather having dynamic policies, we can make sure that we bind API security with the business needs that we have, and build a dynamic behavior into the API security. So that's the intention of having that multifaceted API security, not just authentication and authorization, creating APIs with specific API security model. So it has to be dynamic. Any questions around the concept that I shared?
in the dynamic decision-making policy thing,
Yeah.
is there any API involved or AI involved actually, or is it like set of business rules being validated and stored into the decision store?
So if you look at from the architectural perspective, the policy engine should support any type of decisioning mechanisms.
Yeah.
So the policy engine should have a way of integrating into an AI system, right? Pass that metadata into an AI system and get the decisioning.
Yeah.
And as well as it should be able to integrate with different integration architectures like eventing architectures or API-based architectures into external systems. Or it should be able to host or create business policies within itself. So within Ws2 what we have is, we have a decisioning engine, and it's basically a real-time eventing engine. We call it. We have built a language called Siddhi, and we call it as real-time event processing engine. And it have this concept called publishers and subscribers or consumers. So it provides integration endpoint to publish in decisions and as well as go into other systems and make decisions. So yes, AI systems can be part of that.
So in itself, in the real-time decision-making process, is AI involved to make those decisions, or are they just the business rules?
They are as today, it's just business rules,
Yeah.
but it has a mechanism to integrate. So because if you look at these policies, they are actually a workflow, right?
Yeah.
So they are making decisions sequentially and probably in a graph pattern as well, and you can bring in that AI engine into the, let's say, sequence as a step, and you send metadata, take a decision, and come back to the sequence.
Yeah.
So we can do that in the decision. So basically the message is to, when it comes to API security, it has to be dynamic. So there's nothing called like, okay, this API is secure using API keys. So the same API should be able to expose in different security models, and as well as different validations that you have on that API should be dynamic, right? Based on the consumer, based on the maybe region, it has to change, and it will be supported by a modular implementation, because you can have different modules taking control of different aspects of API security. So it's important to think like where the hackers had, so so when you define an API, right, you not only define the API data model, you define the behavior as well, like this is secured using this security model, because now if you go back to this, the first Swagger definition, let me go back to that. This is the standard Swagger definition, but usually what we see is these Swagger definition, standard Swagger definition is extended by platform specific metadata. All the API products have additional metadata which defines where this API is deployed, which API gateway, in which way. There will be additional more elements in this definition. So they bring more capability into this API definition, which meaning the person who is reading the Swagger definition will have more information about how the API is being deployed, how it is being used. So there will be more internal information available on the Swagger definition. So now you are providing the information for the consumer as a developer, but still you need to make sure that the behavior that you define on the Swagger definition is fully tested, right? You are not exposing any vulnerabilities on the behavior that you define on the Swagger definition. So it is important that you have a good test suite, which basically made up of different combinations of API usages, starting from different query patterns, different payloads. You need to make sure that the behavior is protected, because these are publicly available endpoints, right? Although they are secured, they are publicly available. Right? So you have to be careful. You have to have a right balance. You expose yourself, and as well as you need to protect yourself as well. And this protection can come from different components in the value chain. It can be firewall, it can be API gateway, and even it can be at the back end as well. But what you need to do is you need to, so if you are rejecting a request, you need to do it at the earliest possible step in this request path. Doing it at the backend services, not going to work, because you have already spent many CPU cycles with each hop, right? It's like fail fast, right? But again, you need to encourage the API consumption as well. So the question is, what is the right balance, right? And the fact that when it comes to API security, you need to think not only the authentication and authorization, you need to think about throttling, monitoring, and all the other aspects that comes with that. That's called API security, not just authentication and authorization. And even the other thing is, as you said, AI, right? So there are systems that change themselves dynamically based on the usage as well, like resource allocation. If you see that API being used more between, say, 12 to 1 in a day, the API gateway should be able to allocate resource based on previous patterns to serve those APIs. That's where the dynamism is. And so when you're saying you're making the API capacity available, means that you're not bringing down the system because of this spike, right? So you are able to navigate through that spike. Things like retail APIs in Black Fridays, right? So yeah, without manually modifying something, the API system should be able to identify those spikes, increases, and scale, and as well as establish. And the other thing is, now if you look at the API gateway has multiple APIs, and these APIs can be like, okay, you have REST APIs, you have web sub APIs, GraphQL. They have their own way of establishing security and as well as resource consumption, but they will run on the same runtime, right? Otherwise, like the other model is like you put GraphQL APIs on a separate container, REST on something else, something like that. Usually what happens is you deploy everything into one data plane, right? And between these APIs, you should be able to handle resources as well, right? Usually the GraphQL APIs are resource intensive because there are, you never know the depth the API query will go, right? Because the consumer has the ability to define what level of information that you will get out of the GraphQL query, right? So yeah, so you need to, you should have a system which allows you to build a dynamism based on the usage and the consumption pattern. And then especially with regards to API tokens, API token has a life cycle, token life cycle. You need to refresh, you need to issue tokens, refresh tokens, sometimes reject tokens. So there's a life cycle attached to that API security model. So again, you need to have that frictionless ability, like build that API token management cycle. So developers will be they will find it is easy to consume that API because you have those endpoints and developer tooling to get that token life cycle established. Yeah, so that's what I want to kind of share. Thank you for participating.